In the vast darkness between stars, worlds exist that would shatter the sanity of anyone who witnessed them. Planets where glass falls sideways at the speed of sound, where metals rain from boiling skies, where diamonds precipitate through atmospheres hot enough to vaporize steel. These are not the fevered imaginings of science fiction writers, but the documented realities of worlds that orbit distant suns, places where the very laws of physics seem bent toward creating the most terrifying environments the universe can devise. Beyond our darkest nightmares, hidden within the cosmic depths that stretch beyond our solar system, astronomers have uncovered worlds so fundamentally hostile to existence that they challenge our very conception of what a planet can be. For decades, we assumed that other worlds would resemble the familiar terrestrial bodies of our own neighborhood, perhaps warmer like Venus, perhaps colder like Mars, but operating within recognizable parameters of temperature, pressure, and atmospheric composition. The reality that modern astronomy has unveiled defies these comfortable assumptions and reveals a universe where planetary environments exist in states of perpetual violence that exceed our most apocalyptic imaginings. The first hints of these cosmic nightmares emerged in the 1990s with the discovery of hot Jupiters, massive gas giants orbiting so close to their stars that they complete full revolutions in mere days rather than years. Yet even these early discoveries, shocking as they were to planetary formation theories, represented only the beginning of a revelation that would reshape our understanding of planetary science. As detection methods improved and space-based telescopes peered deeper into the atmospheres of distant worlds, scientists began to catalog conditions that seemed designed by nature's cruelest impulses. HD 189733b, the first exoplanet to have its atmospheric composition analyzed, appeared from a distance as a beautiful cobalt blue marble reminiscent of Earth's oceanic splendor. This resemblance proved to be cosmic mockery of the most profound kind. The blue coloration comes not from water but from silicate particles suspended in an atmosphere where glass rain falls sideways at speeds exceeding 5,400 miles per hour. The discovery marked a turning point in exoplanet science, revealing that familiar appearances could mask conditions so alien that they required entirely new categories of atmospheric physics. What defines a truly scary planet extends far beyond simple hostility to human life. Venus, after all, maintains surface temperatures hot enough to melt lead and atmospheric pressures that would crush submarines, yet it operates within familiar chemical and physical frameworks. The worlds that have earned the designation of cosmic horror chambers possess characteristics that violate our fundamental assumptions about how planets should behave. They are places where water burns while remaining solid, where metals evaporate into clouds that rain molten iron, where the very rocks of the planetary surface join the water cycle by vaporizing into atmospheric circulation patterns. The phenomenon extends beyond atmospheric conditions to the fundamental physics of planetary existence. WASP 76b experiences temperatures so extreme that iron vaporizes on the dayside and condenses into liquid droplets on the cooler nightside, creating weather systems where molten metal falls from the sky in permanent, planet-spanning storms. These are not temporary conditions or seasonal variations, but the steady-state environment of worlds where the basic elements that compose rocky planets exist in states unknown anywhere in our solar system. The horror deepens when we consider that these extreme conditions often arise from the same fundamental forces that shaped our own world. Gravity, stellar radiation, atmospheric chemistry, and orbital mechanics, the familiar components of planetary science, combine in configurations that transform life-giving processes into mechanisms of destruction. The greenhouse effect that warms Earth to habitable temperatures becomes a runaway furnace on other worlds, creating surface conditions hot enough to vaporize mountains. Tidal forces that create our familiar ocean cycle stretch entire planets into egg-like shapes as their host stars literally pull them apart. Perhaps most disturbing are the worlds currently being consumed by their own stars in real-time cosmic cannibalism. WASP 12b orbits so close to its host star that gravitational forces have stretched it into an elongated shape, while the stellar wind strips away planetary material at rates that will completely consume the world within 3 million years. Astronomers can observe this planetary death sentence unfolding in telescopic detail, watching as an entire world slowly feeds itself to its stellar executioner. The catalog of planetary nightmares continues to expand as our observational capabilities improve. Pulsar planets orbit the ultradense remnants of exploded stars, bathed in radiation so intense that it would deliver lethal doses every second for billions of years. Rogue planets drift through interstellar space in eternal darkness, frozen to temperatures approaching absolute zero, while maintaining internal heat that creates geological processes unlike anything seen on planets with stellar companions. Super-Earths possess gravitational fields so strong that human bones would shatter under their own weight, while maintaining atmospheric pressures that could crush our most advanced deep-sea vessels. The implications extend far beyond astronomical curiosity. Each of these worlds represents a natural experiment in extreme physics, revealing how matter behaves under conditions impossible to replicate in terrestrial laboratories. The glass storms of HD 189733b teach us about atmospheric dynamics under supersonic wind conditions. The diamond rain of carbon planets demonstrates high-pressure chemistry that could revolutionize materials science. The iron precipitation of ultra-hot Jupiters shows us metallic phase transitions in atmospheric contexts. Yet perhaps the most profound lesson these worlds offer concerns the extraordinary nature of Earth's habitability. Current estimates suggest that over 5,500 confirmed exoplanets have been discovered, with the vast majority maintaining conditions completely incompatible with any known form of life. The narrow range of temperatures, pressures, and chemical compositions required for biology appears to be achieved by less than 1% of known worlds, making Earth not just a rare sanctuary but a cosmic accident of hospitability in a universe that seems designed to prevent rather than encourage the emergence of life. As we stand on the threshold of a new era in exoplanet discovery, with the James Webb Space Telescope and next-generation ground-based observatories poised to reveal thousands of new worlds, we do so with the knowledge that we are exploring a universe where our worst nightmares about alien environments represent not science fiction, but scientific reality. The coming decades will undoubtedly uncover worlds even more extreme than those already cataloged, places where the fundamental forces of nature combine in ways that challenge our understanding of physics itself. These cosmic chambers of horror await our continued exploration, each one a reminder that in the vast expanse of space, Earth's gentle climate and breathable atmosphere represent not the natural state of planets, but an extraordinary exception to the universe's apparent preference for creating worlds designed to destroy rather than nurture life. 2. The Glass Storm World, HD 189733b. Among the first worlds to reveal the universe's capacity for atmospheric cruelty stands HD 189733b, a planet whose very appearance serves as a cosmic deception of the most malevolent kind. 64.5 light-years distant in the constellation Vulpecula, this world presents itself to telescopic observation as a brilliant cobalt blue sphere, its azure surface bearing such striking resemblance to our own planet that early observers might have mistaken it for a distant twin of Earth. The similarity ends with color alone, for HD 189733b represents not a sanctuary of familiar blue skies and gentle weather, but rather the universe's most thoroughly documented vision of meteorological hell. The planet's blue hue, so reminiscent of Earth's life-giving oceans, originates from an entirely different and far more sinister source. The cobalt coloration comes from silicate particles suspended throughout the planet's atmosphere, microscopic fragments of what would be glass or sand on Earth, but which exist here in a state of permanent atmospheric suspension. These particles create the blue wavelength scattering that gives the planet its deceptively beautiful appearance. Yet they represent the raw material for the most extreme weather phenomenon ever documented in the known universe. HD 189733b completes its tortured orbit around a K-type star every 22 Earth days, racing through space at a distance of just 45 million miles from its host star, 7 times closer than Mercury orbits our Sun. This proximity subjects the planet to gravitational forces so intense that one hemisphere remains permanently locked facing the star, while the other experiences eternal night, creating temperature differentials that drive atmospheric dynamics unlike anything in our solar system. The dayside endures temperatures reaching 1,212 Kelvin, approximately 939 degrees Celsius, hot enough to vaporize silicate rock into gaseous form and maintain an atmosphere of molten minerals. The physics of this world's weather system operate on principles that challenge our fundamental understanding of atmospheric science. On the perpetually illuminated hemisphere, surface temperatures climb hot enough to transform solid rock into vapor, launching silicate particles into atmospheric circulation patterns driven by temperature differentials that span entire planetary hemispheres. The extreme heating creates convective currents of unprecedented scale, with rising columns of superheated gas carrying vaporized rock particles into the upper atmosphere, where they begin their journey around the planet. What emerges from this process represents atmospheric violence on a scale that dwarfs the most powerful storms in Earth's geological history. Winds reaching speeds of 8,700 kilometers per hour, more than 7 times the speed of sound, transport the vaporized silicate from the furnace-like dayside to the cooler nightside hemisphere. To comprehend the scale of these atmospheric currents, consider that Earth's most powerful hurricane winds rarely exceed 300 kilometers per hour, while the jet streams that drive our global weather patterns move at roughly 200 kilometers per hour. HD 189733b maintains constant atmospheric circulation at speeds that would disintegrate any aircraft ever built by human engineering. The true horror of this world's weather reveals itself as these supersonic winds carry their cargo of vaporized glass into the cooler regions of the planet's nightside. Here, temperatures drop to approximately 973 Kelvin, still hot enough to melt copper, but sufficiently cool to allow the silicate vapor to condense back into solid particles. The result is precipitation unlike anything witnessed in our solar system. Rain composed entirely of glass droplets, each fragment formed from condensed rock vapor and accelerated to hypersonic velocities by winds that exceed the speed of military fighter jets. The orientation of this glass precipitation adds another layer of terror to an already nightmarish scenario. Unlike Earth's gravity-driven vertical rainfall, the glass storms of HD 189733b fall horizontally, driven by atmospheric currents so powerful that they overwhelm the planet's gravitational field. The result is a permanent sideways glass storm that encircles the entire world, with razor-sharp silicate fragments traveling at speeds that would make bullets seem sluggish by comparison. Any object encountering this environment would face constant bombardment from glass shards moving at velocities sufficient to penetrate any known material. Recent spectroscopic analysis using the espresso spectrograph has revealed additional atmospheric horrors that compound the world's already lethal conditions. The planet's atmosphere contains not only the deadly silicate particles but also significant quantities of water vapor, methane, carbon monoxide, and trace metals including sodium and lithium. This chemical cocktail creates a toxic environment where the glass storms represent only one of multiple pathways to instantaneous death. The carbon monoxide concentrations alone would prove lethal within minutes, while the metallic components would cause heavy metal poisoning even in minimal exposure scenarios. The discovery of HD 189733b in 2005 marked a turning point in our understanding of exoplanet atmospheric science, shattering the comfortable assumption that distant worlds would operate according to familiar meteorological principles. When astronomers first detected the planet using transit photometry, its size and orbital period immediately indicated extreme temperature conditions. But the full scope of its atmospheric violence only became apparent through years of detailed spectroscopic observation. The planet became the first exoplanet to have its atmospheric composition analyzed in detail, revealing conditions so alien that they required the development of entirely new theoretical frameworks for understanding planetary weather. Perhaps most disturbing is the realization that HD 189733b's glass storms represent a steady-state condition rather than a temporary atmospheric disturbance. The extreme temperature differential between day and night hemispheres ensures that the glass precipitation cycle continues indefinitely, maintained by the same stellar heating that originally created the conditions. This is not weather in the terrestrial sense of temporary atmospheric variations, but rather a permanent state of atmospheric warfare where the planet's own geology participates in an endless cycle of vaporization, transport, and precipitation. The implications extend beyond the immediate horror of the conditions themselves. HD 189733b demonstrates that the familiar blue coloration we associate with habitable, water-bearing worlds can serve as cosmic camouflage for environments designed to destroy rather than sustain life. The planet's appearance serves as a reminder that the universe specializes in creating beautiful facades that mask conditions of unimaginable hostility, forcing astronomers to look beyond visual appearance to understand the true nature of distant worlds. As we continue to discover similar worlds throughout our galaxy, HD 189733b stands as the archetype of atmospheric deception. A world where the sky itself has become a weapon, where the very air consists of glass fragments accelerated to hypersonic velocities, and where the planet's beautiful blue appearance serves only to lure observers into contemplating conditions that represent the universe's capacity for transforming the familiar physics of weather into instruments of cosmic terror. 3. Worlds where metals reign, WASP-76b and iron precipitation. If the sideways glass storms of HD 189733b represented the universe's introduction to atmospheric brutality, then the metallic nightmares of WASP-76b serve as its graduate course in planetary horror. 634 light-years distant in the constellation Pisces, this world pushes the boundaries of atmospheric violence beyond mere silicate precipitation into realms where the fundamental building blocks of planetary geology participate in weather cycles that defy every terrestrial understanding of meteorology. Here, in conditions that transform solid metals into atmospheric components, we encounter a planet where iron itself falls from the sky in molten droplets, creating precipitation patterns that would dissolve spacecraft before they could crash to the surface. WASP-76b belongs to the class of worlds known as ultra-hot Jupiters, gas giants that orbit so close to their host stars that atmospheric temperatures exceed those found in steel foundries. The planet completes its tortured revolution around an F-type star every 18 Earth days, racing through space at a distance that places it well within what would be the orbit of Mercury in our solar system. This proximity subjects the world to stellar radiation so intense that the very concept of solid matter becomes irrelevant across vast regions of the planetary atmosphere, transforming familiar elements into gaseous components of weather systems that operate according to principles unknown anywhere else in the cosmos. The physics of WASP-76b's atmospheric composition reveal conditions that push the periodic table into states of matter that exist nowhere in our solar system. Dayside temperatures climb to 2,500 Kelvin, approximately 2,227 degrees Celsius, hot enough to vaporize not only iron but also titanium, vanadium, and chromium into gaseous form. At these temperatures, the distinction between solid surface and gaseous atmosphere becomes meaningless, as the intense stellar heating creates a planetary environment where metals that form the structural foundation of rocky worlds exist only as components of atmospheric circulation patterns driven by temperature differentials that span thousands of degrees. The planet's tidally locked nature creates a permanent division between a dayside furnace and a comparatively cooler nightside, establishing the temperature gradient necessary to drive the most extreme atmospheric circulation documented in astronomical observation. Powerful winds reaching velocities of 18,000 kilometers per hour transport vaporized metals from the stellar-facing hemisphere to regions where temperatures drop sufficiently to allow metallic condensation. This creates a planetary-scale conveyor belt of vaporized iron, titanium, and other heavy elements, moving through atmospheric currents that operate at speeds exceeding anything witnessed in our solar system. The condensation process that occurs as these metallic vapors encounter the cooler nightside regions represents atmospheric chemistry of unprecedented violence. As temperatures drop from the 2,500 Kelvin dayside furnace to the relatively moderate 1,500 Kelvin of the nightside, still hot enough to melt copper, the vaporized iron begins to condense into liquid droplets suspended within the planet's hydrogen-helium atmosphere. These droplets grow in size as they accumulate additional metallic material from the continuous atmospheric transport, eventually becoming heavy enough to fall through the thick gaseous envelope as literal iron rain. The scale of this metallic precipitation defies comprehension when measured against terrestrial weather phenomena. Each droplet of liquid iron measures temperatures of approximately 1,500 degrees Celsius as it falls through atmospheric layers composed primarily of hydrogen and helium mixed with vaporized metals. The precipitation occurs continuously across the nightside hemisphere, creating a permanent metallic storm system where molten iron falls from clouds composed of condensed metal vapor. The energy released by this process generates atmospheric heating that contributes to the wind patterns that maintain the cycle, creating a self-sustaining system of metallic weather that has persisted for millions of years. Recent observations using the espresso spectrograph have revealed the detailed signature of this iron precipitation through spectroscopic analysis of starlight filtered through the planet's atmosphere during transit events. The detection of neutral iron atoms on the night side, combined with the absence of iron signatures on the day side where temperatures maintain complete vaporization, confirms the reality of conditions where familiar metals participate in atmospheric cycles. The observations represent the first direct evidence of metallic precipitation in an exoplanet atmosphere, documenting weather patterns that were previously relegated to theoretical speculation about extreme planetary environments. The atmospheric composition of WASP-76b extends beyond iron to include a comprehensive catalog of vaporized metals that would form the core and mantle of terrestrial planets. Spectroscopic analysis has detected magnesium, calcium, chromium, manganese, and other heavy elements in gaseous form throughout the planetary atmosphere. This metallic soup creates atmospheric chemistry where the components typically locked away in planetary interiors participate directly in meteorological processes, forming clouds of condensed metal vapor that generate precipitation consisting of multiple metallic species. The implications for any theoretical visitor to this world paint a picture of destruction through multiple simultaneous pathways. The dayside hemisphere maintains temperatures sufficient to vaporize any known spacecraft material within seconds of exposure, while the nightside subjects incoming objects to bombardment from molten metal precipitation at 1,500 degrees Celsius. The atmospheric composition itself consists of hydrogen and helium mixed with vaporized metals, creating a breathing environment that would prove instantly lethal through multiple mechanisms including thermal injury, metal poisoning, and asphyxiation. The winds that drive this metallic weather system operate at velocities that would tear apart any structure designed according to terrestrial engineering principles. Atmospheric currents moving at 18,000 kilometers per hour transport not just gases, but suspended metallic particles and droplets, creating a sandblasting effect where the abrasive material consists of liquid metal heated to foundry temperatures. The combination of extreme velocity and metallic composition would reduce any solid object to component atoms within moments of exposure to the atmospheric circulation. WASP-76b's iron rain represents more than an exotic meteorological phenomenon. It demonstrates the universe's capacity for transforming familiar elements into weapons of atmospheric destruction. The metals that form the foundation of technological civilization become agents of annihilation when subjected to the extreme conditions that prevail on worlds orbiting close to their host stars. Iron, the element that enabled human industrial development and technological advancement, exists here only as components of weather systems designed to destroy rather than build. As astronomical surveys continue to identify similar ultra-hot Jupiters throughout our galaxy, WASP-76b stands as the prototype for worlds where metallurgy becomes meteorology, where the periodic table participates in atmospheric violence, and where the familiar elements of planetary formation serve as ammunition for cosmic storms that rain molten death from metal-laden skies. 4. The burning ice paradox. Gliese 436b. While the metallic storms of WASP-76b demonstrate the universe's ability to weaponize familiar elements through extreme heat, the cosmos reserves its most psychologically disturbing revelations for worlds that violate the fundamental properties of matter itself. 30 light-years distant in the constellation Leo, a world exists that challenges not merely our expectations about planetary environments, but our basic understanding of how physical reality operates. Gliese 436b, officially designated Awohali in the nomenclature of exoplanet naming, presents conditions so paradoxical that they seem to mock the very laws of physics, creating a planetary environment where water burns at temperatures that would melt lead while simultaneously maintaining solid crystalline structures that should be impossible under any known physical framework. This Neptune-sized world orbits a red dwarf star with mechanical precision, completing its revolution every 264 Earth days at a distance that places it well within what astronomers term the stellar roasting zone. The proximity subjects Gliese 436b to constant stellar radiation that maintains surface temperatures of 712 Kelvin, approximately 439 degrees Celsius, hot enough to melt zinc and approach the melting point of lead. Under normal physical circumstances, water exposed to such temperatures would instantly vaporize into superheated steam. Yet this world maintains vast quantities of water in solid form through mechanisms that seem to violate everything we understand about matter's behavior under extreme conditions. The key to this impossible situation lies in gravitational forces so extreme that they overwhelm the thermal energy attempting to transform ice into vapor. Gliese 436b possesses 221 times the mass of Earth compressed into a volume only slightly larger than Neptune, creating gravitational fields that generate pressures exceeding 20,000 Earth atmospheres throughout much of the planetary interior. These crushing forces compress water molecules into exotic crystalline phases that remain stable at temperatures where normal ice would not merely melt, but explosively vaporize into expanding clouds of superheated steam. The ice that exists within Gliese 436b bears no resemblance to the familiar frozen water of Earth's polar regions. Instead, the planet harbors vast quantities of Ice 7 and Ice X, exotic phases of water that form only under pressures equivalent to those found in Earth's deepest mantle regions. These crystalline structures maintain their solid state through the sheer mechanical force of gravitational compression, creating a substance that burns to the touch while retaining the organized molecular structure of frozen water. The result represents a cosmic violation of intuitive physics, where temperature and pressure combine in configurations that create matter existing in states unknown anywhere in our solar system. The atmospheric chemistry of Gliese 436b compounds the world's physical impossibilities with chemical paradoxes that have forced astronomers to reconsider fundamental theories of atmospheric evolution. Early models predicted that a world of this mass and temperature should maintain substantial quantities of methane in its atmosphere, yet observations reveal methane concentrations approximately 7,000 times lower than theoretical calculations suggested. Instead, the atmosphere contains abundant carbon monoxide, a gas that should not exist in significant quantities at the temperatures and pressures that prevail in this world's atmospheric layers. This chemical impossibility suggests atmospheric processes operating according to principles unknown in our solar system. The expected methane should have been destroyed by stellar ultraviolet radiation, but the replacement carbon monoxide should itself be unstable under the same radiation conditions. Some theoretical models propose that the planet's magnetic field creates radiation-shielded regions where carbon monoxide can persist, while others suggest atmospheric chemistry involving reactions between exotic ice phases and gas phase carbon compounds. Each proposed explanation requires atmospheric physics that operates outside the boundaries of currently understood chemical processes. The planet's slow death adds another layer of horror to its already impossible physical state. Gliese 436b is gradually evaporating, losing atmospheric material to space at rates that have already stripped away approximately 10% of its original gaseous envelope. The escaping atmosphere creates a trailing hydrogen cloud that follows the planet in its orbit like a cosmic funeral shroud, visible to telescopic observation as evidence of a world slowly bleeding itself into the vacuum of space. This atmospheric death sentence operates on timescales of hundreds of millions of years, ensuring that any observer could witness the gradual suicide of an entire planetary atmosphere. The process of atmospheric escape occurs through mechanisms unique to worlds orbiting red dwarf stars. The stellar radiation, while less intense than that produced by sun-like stars, maintains constant output over geological timescales that stretch into billions of years. This steady bombardment gradually strips away the lighter elements of the planetary atmosphere while the exotic ice interior continues to outgas replacement materials, creating a cycle where the planet simultaneously destroys and regenerates its atmospheric envelope in a process that guarantees eventual atmospheric death. Recent observations using advanced spectroscopic techniques have revealed additional atmospheric mysteries that deepen rather than resolve the paradoxes surrounding this world. The detection of water vapor in the upper atmosphere, existing simultaneously with solid ice phases in the planetary interior, creates conditions where the same molecular compound exists in multiple phases separated by only hundreds of kilometers of planetary radius. The atmospheric water vapor maintains temperatures of several hundred degrees Celsius while the interior ice remains solid under gravitational compression, creating a world where water simultaneously burns and freezes according to its position within the planetary structure. The implications for any theoretical exploration of Gliese 436b paint a picture of destruction through physical impossibility rather than conventional environmental hostility. Visitors would encounter atmospheric temperatures hot enough to cause fatal burns within minutes, while simultaneously facing the gravitational effects of a world where surface gravity exceeds twice Earth's strength. The exotic atmospheric chemistry would prove lethal through multiple pathways, with carbon monoxide concentrations sufficient to cause unconsciousness within minutes and water vapor at temperatures that would cause respiratory tissue damage through thermal inhalation injury. The burning ice of Gliese 436b represents perhaps the most psychologically disturbing category of planetary nightmare. Worlds where the familiar substances of terrestrial existence behave according to alien physics that violate fundamental expectations about material properties. Water, the molecule essential to all known life and the substance most familiar to human experience, becomes an agent of thermal destruction while maintaining crystalline structures that should not exist under any combination of temperature and pressure accessible to normal matter. This world stands as proof that the universe delights in creating conditions that challenge not merely survival, but sanity itself. Places where the most basic assumptions about physical reality collapse into paradox, where ice burns and water crystallizes under conditions that mock our understanding of matter itself, creating planetary environments designed to shatter both bodies and minds through the simple impossibility of their existence. V. Diamond Rain and Carbon Nightmares, 55 Cancri E. While Gliese 436b torments visitors with the paradox of matter behaving impossibly, the universe reserves an entirely different category of horror for worlds where familiar substances transform into instruments of destruction through sheer abundance. Beyond the realm of impossible ice and burning water lies a class of worlds where the very elements that humans prize as precious become agents of atmospheric violence. 41 light-years distant in the constellation Cancer, orbiting a sun-like star in a system visible to the naked eye, exists a world where diamonds fall from the sky like deadly hail, where the carbon that forms the foundation of all terrestrial life has been concentrated into a planetary nightmare that transforms the most valuable substance on Earth into ammunition for cosmic storms. 55 Cancri E, known to some as Janssen, represents the extreme end of carbon-rich planetary formation, a super-Earth where the element that enables life on our world has been concentrated into proportions that create geological and atmospheric processes unlike anything witnessed in our solar system. This world contains at least 33% carbon by mass, compared to Earth's negligible carbon content, creating a planetary environment where the familiar chemistry of organic molecules gives way to processes that operate according to principles of high-pressure physics that push carbon atoms into crystalline structures of unprecedented size and purity. The planet's extraordinary mass, 8 times that of Earth compressed into a sphere twice our planet's diameter, creates gravitational conditions that generate pressures throughout the planetary interior exceeding those found in the deepest regions of terrestrial diamond mines. Surface gravity reaches 14 times Earth's strength, sufficient to crush human bone structure over extended periods, while internal pressures climb to levels that transform carbon atoms into crystalline diamond structures through mechanisms that operate continuously throughout the planetary mass. The result is a world where diamonds form not through rare geological processes, but as the natural consequence of planetary-scale carbon chemistry operating under extreme gravitational compression. The orbital characteristics of 55 Cancri E compound its carbon-rich horrors with thermal conditions that push atmospheric chemistry into realms of unprecedented violence. The planet races around its host star at a distance of just 0.001544 astronomical units, 25 times closer than Mercury orbits our Sun, completing its revolution in just 18 Earth hours. This proximity subjects the world to stellar radiation so intense that dayside surface temperatures exceed 3,500 degrees Celsius, hot enough to maintain permanent lava oceans composed not of familiar silicate rocks, but of molten carbon compounds that exist nowhere else in the known universe. The atmospheric composition of this world reads like a catalog of toxic death, with carbon dioxide and carbon monoxide forming the primary atmospheric components alongside trace quantities of hydrogen cyanide. A compound so lethal that concentrations of just 300 parts per million prove fatal to human physiology within minutes. The atmospheric pressure, measuring 14 times Earth's surface pressure, ensures that these toxic gases remain in close contact with any surface materials, creating environmental conditions where the very air would prove lethal through multiple simultaneous pathways including poisoning, thermal injury, and chemical burns. Recent observations using the James Webb Space Telescope have confirmed the existence of substantial atmospheric layers surrounding 55 Cancri E, validating theoretical models that predicted carbon-rich worlds could maintain stable gaseous envelopes despite extreme stellar heating. The spectroscopic analysis revealed not only the expected carbon dioxide and carbon monoxide, but also complex atmospheric chemistry involving interactions between gas-phase carbon compounds and the planetary surface. These observations represent the first detailed atmospheric analysis of a carbon planet, documenting conditions where carbon chemistry operates according to principles unknown anywhere in our solar system. The diamond precipitation process that theoretically occurs on 55 Cancri E represents atmospheric violence of unprecedented elegance and terror. The extreme surface temperatures vaporize carbon compounds into atmospheric circulation patterns driven by the temperature differential between the furnace-like dayside and the relatively cooler nightside regions. As these carbon vapors rise into the atmospheric layers, they encounter pressure and temperature conditions that force carbon atoms into diamond crystalline structures while still suspended in the gaseous envelope. The resulting diamond formation occurs not in underground geological processes, but in atmospheric layers exposed to direct observation through telescopic analysis. Theoretical models suggest that diamond crystals forming in the upper atmosphere could grow to substantial sizes before becoming heavy enough to fall through the thick carbon dioxide atmosphere. The precipitation would consist of genuine diamond hailstones, each fragment representing carbon atoms compressed into crystalline perfection by atmospheric pressure and then accelerated to terminal velocity through the dense gaseous envelope. The scale of this diamond precipitation defies terrestrial comprehension when measured against Earth's most valuable substances. A single storm on 55 Cancri E could theoretically produce diamond precipitation equivalent to the entire terrestrial diamond mining output across geological timescales. The continuous atmospheric processes that maintain these conditions ensure that diamond formation represents not a rare geological event, but the steady-state atmospheric chemistry of a world where carbon abundance creates precipitation patterns involving the most prized mineral substance known to human civilization. The surface conditions beneath these diamond storms paint a picture of destruction through geological processes that operate according to alien principles. The permanent lava oceans consist not of familiar silicate magma, but of molten carbon compounds maintaining temperatures that exceed industrial furnace capabilities. The interaction between these liquid carbon surfaces and the diamond precipitation creates geological chemistry where solid diamond dissolves back into liquid carbon phases, only to be vaporized again by stellar heating in a cycle that maintains perpetual carbon weather systems. The implications for any theoretical visitor to 55 Cancri E extend beyond the immediate threat of diamond bombardment to encompass destruction through exotic carbon chemistry. The atmospheric hydrogen cyanide concentrations would prove lethal within minutes, while the carbon monoxide levels would cause unconsciousness followed by death through cellular asphyxiation. The surface temperatures would vaporize any known spacecraft materials, while the gravitational field would gradually crush bone structure through the simple physics of standing upright in 14 times Earth gravity. Perhaps most disturbing is the realization that 55 Cancri E transforms the element most essential to terrestrial life into an agent of atmospheric destruction. Carbon, the foundation of organic chemistry and the basis for all known biological processes, exists here only as a component of weather systems designed to rain crystalline death from toxic skies, creating a world where life's most fundamental building block serves as ammunition for cosmic storms that demonstrate the universe's capacity for transforming life's necessities into instruments of annihilation. 6. The lava rain planet, Corot 7b. As we venture deeper into the catalog of atmospheric horrors that populate our galaxy, the progression from diamond precipitation to even more fundamental violations of terrestrial physics reveals the universe's systematic dismantling of every assumption we hold about planetary behavior. Beyond worlds where precious stones fall as deadly hail lies a realm where the very bedrock of planetary surfaces abandons its solid state to participate in weather cycles that transform geology into meteorology. For 180 light-years distant in the constellation Monoceros, a world exists where the distinction between surface and atmosphere dissolves into a hellish cycle of vaporized stone, where mountains evaporate into clouds and rain back down as molten pebbles, creating the ultimate nightmare scenario where the ground itself becomes a component of hostile weather systems. Corot 7b represents the logical extreme of rocky planet evolution under conditions of stellar torture. A super-Earth where proximity to its host star has transformed familiar geological processes into atmospheric phenomena that challenge every model of planetary surface dynamics. This world, with 158 times Earth's radius and approximately 5 times our planet's mass, orbits its K-type star at a distance so close that it completes a full revolution in just 204 hours, faster than a single Earth day. The orbital velocity required to maintain this breakneck pace around its stellar companion subjects the planet to gravitational stresses that contribute to the surface conditions, while the proximity ensures that stellar radiation maintains surface temperatures that exceed those found in the hottest terrestrial volcanic eruptions. The temperature extremes that characterize Corot 7b create the most dramatic day-night differential documented in planetary science, establishing conditions where the fundamental state of matter shifts across planetary hemispheres. The day side endures temperatures ranging from 2,200 to 2,500 degrees Celsius, hot enough to maintain permanent oceans of molten lava and sufficient to vaporize quartz, feldspar, and other common rock-forming minerals into gaseous components. Meanwhile, the night side plunges to negative 200 degrees Celsius, creating a temperature span of nearly 2,700 degrees across the planetary surface. A differential that drives atmospheric dynamics operating on principles unknown anywhere else in the cosmos. The rock vapor weather cycle that operates on Corot 7b represents the most alien atmospheric process ever documented, transforming the familiar water cycle of Earth into a geological nightmare where solid planetary crust participates directly in meteorological phenomena. On the superheated day side, surface temperatures sufficient to maintain molten lava seas ensure that rocky materials exist in continuous equilibrium between liquid and gaseous phases. The intense stellar heating vaporizes silicon dioxide, sodium compounds, potassium minerals, and metallic elements into atmospheric circulation patterns that operate according to principles of high-temperature chemistry unknown in terrestrial atmospheric science. The atmospheric composition that results from this continuous rock vaporization reads like a periodic table of geological destruction. Spectroscopic analysis has revealed sodium and potassium as dominant atmospheric components, creating gaseous envelopes where elements typically locked in crystalline structures exist as freely moving atmospheric particles. Silicon monoxide, a compound that forms only under extreme temperature conditions, comprises substantial portions of the atmospheric chemistry, while oxygen freed from silicate bonds creates reactive atmospheric conditions that would prove instantly lethal to any known materials or biological systems. The condensation process that occurs as these rock vapors encounter the frigid nightside regions creates precipitation patterns that represent the ultimate violation of terrestrial weather expectations. As gaseous sodium, potassium, and silicon compounds cool from dayside furnace temperatures to nightside freezing conditions, they condense into solid particles suspended within the thin atmospheric envelope. The pressure differential measuring approximately 1 pascal compared to Earth's 101,325 pascal sea level pressure creates atmospheric conditions where these condensed rock particles can remain suspended until gravitational forces overwhelm atmospheric buoyancy. The resulting precipitation consists of what astronomers have termed pebble rain, solid fragments of condensed rock vapor that fall through the thin atmosphere to impact the molten surface in a cycle that has persisted for millions of years. Each droplet represents stone that was solid surface material hours earlier, vaporized by stellar heating, transported across planetary hemispheres by atmospheric circulation, condensed in the cold of perpetual night, and returned to the surface as precipitation consisting of the fundamental building blocks of terrestrial geology. The scale of this rock weather cycle operates on planetary dimensions that dwarf any terrestrial geological process. The continuous vaporization and condensation of surface materials means that the entire planetary crust participates in atmospheric circulation over geological timescales, with mountains literally evaporating into the atmosphere and raining back down as geological precipitation. The energy requirements for maintaining this process exceed the total energy output of all terrestrial volcanic activity by factors of millions, sustained by stellar radiation that maintains furnace conditions across entire planetary hemispheres. The atmospheric pressure conditions that enable this rock vapor weather represent environmental hostility through near vacuum rather than crushing density. At approximately 1 pascal, roughly equivalent to conditions 90 kilometers above Earth's surface, the atmospheric envelope provides no protection from stellar radiation while maintaining sufficient density to transport vaporized rock particles across planetary distances. Any visitor to this world would face immediate decompression effects similar to exposure to hard vacuum, while simultaneously encountering atmospheric temperatures that would vaporize spacecraft materials and rain consisting of molten stone fragments. The chemical composition of the rock vapor atmosphere creates toxicity through mechanisms unknown in terrestrial atmospheric science. Gaseous sodium and potassium would react violently with any moisture, while silicon monoxide represents a compound so reactive that it exists only under the extreme conditions that prevail in stellar atmospheres. The free oxygen liberated from vaporized silicate minerals would create oxidation reactions so rapid and violent that they would consume any organic or metallic materials within seconds of exposure. Recent theoretical models suggest that the rock vapor cycle of Corot 7b may include precipitation of exotic minerals unknown on Earth, formed through atmospheric chemistry that operates under temperature and pressure conditions impossible to replicate in terrestrial laboratories. Titanium compounds may condense as perovskite minerals, while aluminum and calcium could form atmospheric particles that represent entirely new categories of geological materials created through meteorological rather than traditional geological processes. Corot 7b stands as the ultimate demonstration that the universe recognizes no distinction between geology and meteorology when subjected to conditions extreme enough to vaporize the very foundations of planetary surfaces, creating worlds where the ground itself becomes weather, where mountains join the rain cycle, and where the fundamental materials of planetary formation serve as ammunition for storms that rain stone from skies composed of vaporized continents. 7. Worlds being devoured alive, WASP-12b. From worlds where the very bedrock participates in atmospheric violence, we descend further into cosmic horror to witness perhaps the most psychologically devastating phenomenon the universe has devised: the real-time consumption of entire planets by their own stars. While Corot 7b demonstrates the universe's ability to transform geology into deadly weather, there exist worlds facing an even more fundamental violation of planetary existence: complete annihilation through stellar cannibalism that unfolds across cosmic timescales short enough for astronomers to observe the death sentence in progress. 600 light-years distant in the constellation Auriga, a world designated WASP-12b provides humanity with front-row seats to witness planetary execution, a cosmic death penalty carried out with methodical precision as an entire world slowly feeds itself to its stellar executioner. WASP-12b represents the ultimate nightmare scenario for planetary existence. A world caught in an inexorable spiral toward destruction, stretching and distorting under gravitational forces so extreme that the very shape of the planet has been warped into an elongated egg-like form. This gas giant, slightly more massive than Jupiter but considerably larger due to thermal expansion, orbits its F-type host star at the crushing distance of just 0.0234 astronomical units, closer than any planet in our solar system approaches the Sun. The proximity subjects WASP-12b to gravitational tidal forces that would be devastating even for a solid rocky world, but prove apocalyptic for a gas giant whose atmospheric envelope can be stripped away layer by layer in a process visible to telescopic observation. The physics of planetary consumption operating on WASP-12b demonstrates gravitational violence on a scale that dwarfs any terrestrial understanding of tidal effects. The stellar gravity creates differential forces across the planetary diameter that literally stretch the world into an elongated shape, with the stellar-facing hemisphere drawn into a pronounced bulge that extends toward the host star like a planetary scream frozen in space. The tidal forces exceed the planet's gravitational binding energy in the extended atmospheric regions, creating conditions where stellar gravity overwhelms planetary gravity and begins the systematic dismantling of an entire world. Current measurements indicate that WASP-12b loses material to its host star at a rate of approximately 10 to the power of -7 solar masses per year, equivalent to consuming roughly 100 billion tons of planetary material annually. This mass transfer creates a visible stream of planetary matter flowing from the extended atmosphere into the stellar corona, forming what astronomers term an accretion stream, where the substance of one world literally feeds the nuclear furnace of its stellar companion. The process operates with mechanical inevitability, converting planetary mass into stellar fuel through gravitational forces that admit no possibility of escape or reversal. The timeline for complete planetary consumption represents one of the most precisely calculated cosmic death sentences in astronomical observation. Current orbital decay measurements show that WASP-12b's orbital period decreases by 2981 milliseconds per year, a seemingly tiny variation that accumulates into catastrophic orbital collapse over cosmic timescales. Theoretical calculations based on current mass loss rates predict that the entire planet will be consumed within 29 to 316 million years, a time span that may seem lengthy by human standards but represents an instant in the cosmic timescale of stellar evolution. The atmospheric conditions on this doomed world compound its gravitational torment with thermal extremes that push matter into states unknown anywhere in our solar system. Surface temperatures reach 2,500 Kelvin, approximately 2,200 degrees Celsius, hot enough to maintain an atmosphere expanded to 3 times Jupiter's normal radius, while reflecting only 6% of incident starlight. The planet appears black as asphalt, despite receiving stellar radiation intense enough to vaporize most materials, creating visual conditions where the world absorbs rather than reflects the very energy that drives its destruction. The chemical composition of WASP-12b reveals atmospheric chemistry operating under conditions that create compounds unknown in our solar system. The planet maintains a carbon-to-oxygen ratio of approximately 10, compared to our Sun's ratio of 0.54, indicating carbon-rich atmospheric processes that may include exotic carbon compounds formed under extreme temperature and pressure conditions. This atmospheric chemistry creates molecular structures that exist nowhere else in the known universe, formed through thermal processes that operate at temperatures exceeding those found in most stellar atmospheres. The extended atmosphere that results from extreme stellar heating creates a planetary envelope so distended that it occupies a volume 3 times larger than Jupiter despite possessing similar mass. This atmospheric expansion ensures that the outermost layers exist in a state of perpetual escape, with atmospheric material continuously flowing away from the planet toward the stellar surface. The process creates a cosmic tail of planetary material extending behind the world in its orbit, visible evidence of a planet slowly dissolving into the vacuum of space. The magnetic field interactions between WASP-12b and its host star add another layer of violence to the planetary destruction process. The intense stellar magnetic field induces electrical currents in the planetary atmosphere that generate heating effects contributing to atmospheric expansion and mass loss. These magneto-hydrodynamic interactions create conditions where the planet's own atmospheric circulation becomes a mechanism for accelerated self-destruction, converting orbital energy into heat that drives additional atmospheric escape. Recent observations using advanced spectroscopic techniques have revealed the detailed signature of planetary destruction through direct measurement of material flowing from planet to star. The detection of planetary atmospheric components in the stellar spectrum provides confirmation that astronomers are witnessing active planetary consumption rather than theoretical mass loss. The observations represent the first direct evidence of real-time planetary destruction, documenting the death of a world through mechanisms that operate on timescales accessible to human observation. The implications for any theoretical visitor to WASP-12b encompass destruction through multiple simultaneous mechanisms that ensure death long before reaching the planetary surface. The extreme tidal forces would stretch and tear apart any solid object, while the 2,200-degree atmospheric temperatures would vaporize spacecraft materials within seconds. The radiation environment approaches stellar intensity levels, creating conditions equivalent to flying directly into the outer layers of a star, while experiencing gravitational forces that exceed anything accessible through terrestrial physics. WASP-12b stands as proof that the universe specializes in creating scenarios where entire worlds face cosmic death sentences carried out with methodical precision, demonstrating that planetary destruction represents not a theoretical possibility but an observable reality where gravity itself becomes an instrument of annihilation, slowly consuming worlds through forces that transform stellar systems into feeding grounds for cosmic cannibalism. 8. The undead worlds, pulsar planets. As we witness WASP-12b's methodical consumption by stellar gravity, our journey into cosmic horror reaches a threshold where even the violence of stellar cannibalism pales before the universe's ultimate expression of astronomical brutality. Beyond worlds being devoured by living stars lies a realm where the very concept of stellar death becomes the foundation for planetary nightmare scenarios that exceed every previous category of cosmic terror. Here, in star systems where stellar evolution has reached its most violent conclusion, we encounter worlds that orbit not life-giving suns but the ultra-dense remnants of stellar explosions so catastrophic they have compressed entire star systems into cosmic lighthouses of death that sweep beams of lethal radiation across their surviving planetary companions with mechanical precision. The pulsar designated PSR B1257+12, known by the ominous astronomical designation Lich in honor of mythological undead creatures, represents the ultimate violation of everything we understand about habitable star systems. Located 2,300 light-years distant in the constellation Virgo, this neutron star, the collapsed core of a once massive star that exploded in a supernova of unimaginable violence, spins on its axis 161 times per second while generating magnetic fields measuring between 10 billion and 1 trillion times the strength of Earth's protective magnetosphere. The rotation creates a cosmic lighthouse effect where twin beams of radiation sweep across space with the precision of a cosmic metronome, delivering doses of high-energy particles that would prove instantly lethal to any known form of matter. The three worlds that orbit this stellar corpse, designated Draugr, Poltergeist, and Phobder after creatures of death and nightmare from various mythological traditions, hold the distinction of being the first confirmed exoplanets ever discovered, detected in 1992 through their gravitational effects on the pulsar's radio emissions. Yet this historical significance pales before the cosmic horror of their actual conditions, for these worlds exist in a radiation environment so extreme that it redefines our understanding of hostile planetary environments. The radiation flux that constantly bathes these planets exceeds the background radiation of our solar system by factors measuring in the millions, creating surface conditions where the very atoms of planetary materials undergo continuous bombardment by high-energy particles. The physics of pulsar radiation creates destruction through mechanisms unknown anywhere else in the observable universe. The neutron star's magnetic field accelerates charged particles to velocities approaching the speed of light, generating streams of X-rays and gamma rays that sweep across the planetary system with each 161 times per second rotation. The energy density of this radiation approaches levels found during nuclear weapons detonations, maintained continuously for billions of years in a process that has sterilized these worlds more thoroughly than any conceivable sterilization procedure could achieve on Earth. The radiation intensity measurements for the pulsar planets reveal conditions that challenge comprehension when compared to familiar radiation environments. Where Earth receives approximately 62 millisieverts of natural background radiation annually, the pulsar planets endure constant bombardment measuring thousands of times higher intensity. The radiation levels approach those experienced at ground zero during nuclear explosions, except maintained as the steady-state environment rather than a momentary event. Any biological tissue exposed to these conditions would experience cellular destruction at the molecular level, with DNA strands severed millions of times per second by high-energy photons. The atmospheric conditions on pulsar planets represent environmental hostility through absolute absence rather than toxic composition. No atmosphere can survive in the radiation environment generated by pulsar emissions, as any gaseous envelope would be instantly stripped away by the stellar wind and radiation pressure that sweep constantly across the planetary surfaces. The worlds exist in perfect vacuum, their surfaces exposed directly to hard radiation without even the minimal protection that a thin atmosphere might theoretically provide. The combination of vacuum conditions and extreme radiation creates surface environments where matter itself becomes unstable under constant high-energy bombardment. The formation history of these worlds adds another layer of cosmic horror to their current conditions, suggesting planetary birth through mechanisms involving the most violent events known to stellar evolution. Current theories propose that the pulsar planets formed either from the debris of the supernova explosion that created the neutron star, or through the collision of two white dwarf stars that generated sufficient material to create new planetary bodies. Either scenario involves planetary formation from stellar death and violence, creating worlds literally born from cosmic catastrophe and bathed from their formation in radiation levels that would prove instantly lethal to any known materials or biological systems. The surface conditions that prevail on these undead worlds exist in states of perpetual darkness, punctuated only by the deadly glow of high-energy radiation that sweeps across them with each pulsar rotation. The neutron star provides no warmth, only the cold precision of radiation beams that deliver lethal doses with clockwork regularity. Surface temperatures remain near absolute zero, yet the radiation intensity would prove fatal within seconds to any hypothetical visitor, creating conditions where death would come through radiation exposure before hypothermia could take effect. The magnetic field environment surrounding PSR B1257+12 creates additional hazards that compound the radiation bombardment with electromagnetic effects unknown anywhere in our solar system. The pulsar's magnetic field strength exceeds Earth's magnetic field by factors of 200 billion, generating electromagnetic conditions where the behavior of charged particles follows principles that operate nowhere else in normal stellar environments. These magnetic effects would disrupt any electronic systems while simultaneously creating aurora phenomena that extend far above any possible atmospheric boundaries. The discovery of planets orbiting PSR B1257+12 revolutionized our understanding of planetary formation, while simultaneously revealing the universe's capacity for creating worlds under the most extreme conditions possible. The detection required unprecedented precision in measuring the pulsar's radio emissions, as the gravitational effects of the orbiting planets create variations in the neutron star's rotation timing measurable only in microseconds. The observations demonstrated that planetary formation can occur even in environments subjected to stellar violence beyond anything previously imagined. The implications for planetary formation theory suggest that worlds can survive and even form in conditions that exceed the most extreme scenarios previously considered by astronomical models. The existence of pulsar planets proves that the universe creates worlds in environments where the very concept of habitability becomes meaningless, where planetary surfaces exist only as targets for cosmic radiation bombardment that has persisted unchanged for billions of years since the violent stellar death that created their current environment. These undead worlds stand as monuments to the universe's capacity for creating planetary environments where death comes not through atmospheric violence or crushing gravity, but through the simple physics of radiation exposure maintained at nuclear explosion intensity for geological timescales, creating worlds where the very concept of life becomes a cosmic impossibility maintained by the clockwork precision of stellar remnants that sweep death across their planetary systems with the mechanical certainty of cosmic executioners. 9. The impossible planet, Kepler 78b. While the undead worlds orbiting pulsar remnants demonstrate the universe's capacity for subjecting planets to radiation environments that exceed nuclear warfare, there exists a category of cosmic horror that transcends even the violence of stellar death to challenge the fundamental laws governing planetary existence itself. Beyond radiation bombardment and atmospheric destruction lies a realm where worlds violate the basic principles of planetary formation so thoroughly that their very existence serves as an accusation against our understanding of physics. 400 light-years distant in the constellation Cygnus, a world designated Kepler 78b presents conditions that represent not merely environmental hostility, but a cosmic impossibility that shouldn't exist according to every established model of how planets form, survive, and maintain stable orbits around their host stars. Kepler 78b shatters astronomical convention by completing a full orbital revolution around its sun-like host star in just 85 hours. A period so brief that the planet races through space at velocities that challenge the gravitational mechanics that govern stable planetary systems. The orbital distance required to maintain such breakneck pace places the world at less than 1 million miles from its stellar companion, closer than any planet in our solar system approaches the Sun, and well within the theoretical zone where tidal forces should have long ago torn any planetary body apart into component debris. Yet this world not only survives but maintains a rocky composition remarkably similar to Earth's, creating a cosmic paradox where familiar planetary materials exist in an orbital configuration that violates every principle of planetary formation theory. The fundamental impossibility of Kepler 78b's existence stems from the irreconcilable contradiction between its current orbital position and the physical processes required for rocky planet formation. Current models of planetary system evolution demonstrate that solid materials cannot condense from stellar nebulae at distances this close to host stars, where temperatures exceed those necessary to maintain rocky compounds in vaporized form. The stellar disk that originally surrounded Kepler 78's host star would have been far too hot at this orbital distance to allow the accretion of solid particles into planetary-sized bodies, making in-place formation physically impossible under any known mechanism of planetary birth. The alternative explanation, that Kepler 78b formed at a greater distance and subsequently migrated inward, proves equally impossible when subjected to gravitational analysis. Planetary migration through gravitational interactions with stellar disk material or other planetary bodies operates according to well-understood principles that establish clear limits on how close worlds can approach their host stars before tidal forces overwhelm planetary binding energy. The orbital distance occupied by Kepler 78b falls well within the zone where any migrating planet should have been torn apart by differential gravitational effects long before reaching its current position. Yet despite its theoretical impossibility, Kepler 78b undeniably exists, maintaining orbital stability while enduring surface conditions that push rocky planetary materials to their absolute physical limits. Surface temperatures reach 2,200 Kelvin, approximately 1,930 degrees Celsius, hot enough to maintain the entire planetary surface in a completely molten state. The world exists as a sphere of liquid rock orbiting its star with mathematical precision, its surface a continuous ocean of molten silicate materials heated to temperatures that approach those found in stellar atmospheres. The planetary composition analysis reveals the most disturbing aspect of Kepler-78b's impossible existence. Despite occupying an orbital position where rocky materials should not exist, the world maintains a density of 55 grams per cubic centimeter, nearly identical to Earth's density and confirming a composition of rock and iron virtually indistinguishable from terrestrial planetary materials. The planet possesses 12 times Earth's radius and 169 times our planet's mass, creating a world that represents a scaled-up version of Earth subjected to thermal conditions that maintain permanent surface liquefaction. The atmospheric conditions surrounding this impossible world compound its violations of planetary physics with environmental extremes that ensure destruction through multiple simultaneous mechanisms. The intense stellar heating has stripped away any possible atmospheric envelope, leaving the molten surface exposed directly to stellar radiation without even minimal atmospheric protection. The combination of vacuum conditions and surface temperatures exceeding those of blast furnaces creates an environment where matter exists in states intermediate between solid and gas phases, with surface materials continuously vaporizing and recondensing in cycles driven by stellar heating. The tidal forces operating on Kepler-78b represent gravitational violence approaching the theoretical limits of planetary structural integrity. The differential gravitational acceleration across the planetary diameter creates internal stresses that continuously deform the world's shape while heating the interior through tidal friction effects. These forces generate additional thermal energy that contributes to maintaining the molten surface conditions, creating a feedback loop where gravitational effects reinforce the thermal destruction that characterizes this world's surface environment. Current theoretical models predict that Kepler-78b faces inevitable destruction through the same tidal forces that currently maintain its impossible existence. The orbital decay rate, though measured in fractions of seconds per year, accumulates over cosmic timescales into catastrophic orbital collapse. Calculations based on current tidal heating rates suggest that the planet will spiral into its host star within approximately 3 billion years, making this impossible world also temporary in cosmic terms. The discovery of Kepler-78b forced astronomers to confront the possibility that planetary formation operates according to principles that extend beyond current theoretical frameworks. Some proposed explanations invoke exotic formation scenarios involving stellar evolution, planetary collisions, or gravitational interactions that could theoretically place rocky materials in otherwise impossible orbital configurations. Yet each proposed mechanism requires conditions so specific and unlikely that they approach cosmic coincidence rather than reproducible physical processes. The implications for planetary formation theory extend beyond this single impossible world to question whether our understanding of how planetary systems develop encompasses the full range of physical processes operating in stellar environments. The existence of Kepler-78b suggests that the universe creates worlds through mechanisms that transcend current theoretical limitations, generating planetary bodies in configurations that challenge fundamental assumptions about the relationship between stellar heating, planetary composition, and orbital dynamics. Kepler-78b stands as the ultimate demonstration that the universe refuses to be constrained by human theoretical frameworks, creating worlds that violate established physical principles while maintaining stable existence as cosmic impossibilities that race around their host stars in defiance of every law that should govern planetary behavior, reminding astronomers that cosmic reality consistently exceeds the boundaries of scientific prediction in ways that transform impossibility into observable fact. X. Gravity prisons and crushing worlds. While Kepler-78b confronts us with the impossibility of worlds that violate the fundamental laws governing planetary formation, the universe reserves an entirely different category of horror for planets that exploit gravity itself as an instrument of systematic torture. Beyond the realm of impossible orbits and theoretical violations lies a class of worlds where the force that binds matter together becomes an agent of destruction so thorough that the simple act of existing becomes a form of slow execution. These are the super-Earths and massive rocky worlds where gravity has been concentrated into strengths that transform the familiar physics of standing, breathing, and moving into mechanisms of bodily destruction that operate with the mechanical precision of cosmic torture devices designed to crush visitors through the fundamental force that governs planetary existence. The physics of extreme gravity creates destruction through mechanisms that operate continuously and inescapably, transforming every aspect of physical existence into a struggle against forces that exceed the structural limits of biological and technological systems. Where Earth's surface gravity of 98 meters per second squared provides the baseline against which all terrestrial life has evolved over billions of years, the super-Earths scattered throughout our galaxy demonstrate gravitational conditions that range from merely debilitating to absolutely crushing, creating worlds where the simple physics of circulation, locomotion, and structural integrity become impossible challenges that ensure death through gravitational effects alone. Kepler 452b, often termed Earth's older cousin due to its position within the habitable zone of a sun-like star, exemplifies the deceptive nature of worlds that appear potentially hospitable until gravitational analysis reveals conditions designed to destroy rather than support life. This super-Earth possesses 5 times the mass of our planet compressed into a sphere approximately 60% larger than Earth, creating surface gravity that approaches twice our familiar 1g acceleration. The world orbits within the theoretical habitable zone where liquid water could exist, yet the gravitational field strength ensures that any Earth-based visitor would face immediate physiological challenges that escalate rapidly into life-threatening conditions. The human cardiovascular system, evolved over millions of years to function efficiently under Earth's gravitational conditions, begins to fail when subjected to gravitational fields exceeding twice our planet's strength. At 2g acceleration, the heart must work against doubled gravitational loading to pump blood throughout the circulatory system, creating cardiac stress that leads to rapid fatigue and eventual cardiovascular failure. The venous return system that relies on muscle contractions and valve mechanisms to return blood to the heart operates according to principles that become increasingly inefficient as gravity increases, leading to blood pooling in the extremities and reduced cardiac output that progresses to circulatory collapse. The skeletal system faces even more immediate challenges when subjected to extreme gravitational loading. Human bones, composed primarily of calcium phosphate with organic collagen matrices, possess structural strength adequate for supporting body weight under Earth's gravitational conditions, with substantial safety margins that allow for running, jumping, and other dynamic activities. However, bone strength scales linearly with cross-sectional area while gravitational loading increases with mass, creating a fundamental mismatch where increased gravity exceeds bone structural capacity through simple physics rather than material failure. At gravitational fields approaching 3 times Earth's strength, levels achievable on super-Earths with 8 to 10 times our planet's mass, human bone structure begins to experience stress fractures during normal movement. The femur and tibia, designed to support body weight under 1g conditions, develop hairline fractures that propagate into complete breaks during activities as simple as walking or standing from a seated position. The vertebral column faces compression forces that exceed the structural limits of individual vertebrae, leading to spinal compression fractures that occur spontaneously without external trauma. The respiratory system confronts gravitational challenges that transform the simple act of breathing into exhausting physical labor. The diaphragm and intercostal muscles that drive respiratory mechanics must work against gravitational forces that increase the effective weight of the ribcage and internal organs, requiring exponentially greater muscular effort to achieve the same ventilation volumes. At gravitational fields exceeding 4 times Earth's strength, the respiratory muscles fatigue rapidly during normal breathing, leading to hypoventilation and eventual respiratory failure as the energy cost of breathing exceeds the metabolic capacity of respiratory muscles. Theoretical calculations based on human physiological limits suggest that sustained survival becomes impossible at gravitational fields exceeding 46 times Earth's strength for even the most physically fit individuals. Beyond this threshold, the combined effects of cardiovascular stress, skeletal loading, and respiratory effort exceed the adaptive capacity of human physiology even with technological assistance. The gravitational loading creates a cascade of physiological failures where each system's attempts to compensate for increased gravitational stress accelerates the failure of other organ systems in a process that leads inevitably to death through multiple simultaneous pathways. The super-Earths discovered throughout our galaxy demonstrate gravitational conditions that extend far beyond these theoretical survival limits. Worlds like K2-155d, with masses approaching 10 times Earth's and surface gravity exceeding 35 g, create gravitational fields where human survival would require technological support systems that exceed current engineering capabilities. The energy requirements for mechanical assistance to offset gravitational loading would drain power systems faster than any conceivable portable energy source could provide, making even technologically assisted survival a temporary measure rather than a sustainable solution. The atmospheric conditions on Super-Earth's compound gravitational challenges with pressure environments that create additional crushing effects. Massive planets retain thicker atmospheric envelopes through enhanced gravitational attraction, creating surface pressures that can exceed Earth's sea level pressure by factors of hundreds or thousands. Venus, with its 92 atmosphere surface pressure, provides a local example of crushing atmospheric conditions, but super-Earths can theoretically maintain atmospheric pressures equivalent to those found kilometers beneath Earth's ocean surface. The combination of extreme surface gravity and crushing atmospheric pressure creates environmental conditions where the human body faces destruction through multiple simultaneous compression effects. High atmospheric pressure forces additional nitrogen into solution within body tissues, creating conditions similar to extreme deep-sea diving where nitrogen narcosis impairs cognitive function, while increased pressure differential across lung membranes leads to pulmonary edema and eventual drowning in accumulated bodily fluids. The technological challenges of creating habitable environments under extreme gravitational conditions extend beyond life support to encompass fundamental engineering problems that may prove insurmountable with any conceivable materials or energy systems. Structures designed to provide gravitational shielding would require materials with strength-to-weight ratios that exceed those of any known substances, while the energy requirements for maintaining artificial gravity environments that counteract planetary gravitational effects would exceed the power output of nuclear reactors by factors of thousands. These gravity prisons scattered throughout our galaxy stand as demonstrations that the universe has weaponized the fundamental force responsible for planetary formation itself, creating worlds where gravity becomes an inescapable torture device that crushes visitors through the simple physics of standing upright, transforming the force that binds matter together into an agent of systematic destruction that operates with the mechanical precision of cosmic execution chambers designed to kill, through the fundamental physics of existence itself. 11. Rogue worlds. Planets lost in eternal darkness. Beyond the crushing gravity prisons that transform planetary surfaces into torture chambers through the fundamental force that binds matter together, the universe reserves its most psychologically devastating horrors for worlds that have been severed from the life-giving warmth of stellar companions entirely. Where super-Earths demonstrate the weaponization of gravity against visitors, there exist worlds that embody a more existential terror. Planets cast adrift in the infinite darkness between stars, condemned to wander the cosmic void in eternal night, while their surfaces freeze to temperatures that approach the absolute limit of thermal energy itself. These are the rogue worlds, the orphaned planets ejected from their birth systems through gravitational violence so catastrophic that entire worlds have been flung into interstellar space to drift alone through darkness that stretches across light years of empty void. The discovery of free-floating planets drifting through interstellar space represents perhaps the most profound violation of our fundamental assumptions about planetary existence, revealing that worlds need not orbit stars to maintain their status as planetary bodies. Current estimates suggest that our galaxy contains billions of these cosmic wanderers, more rogue planets than stellar systems, creating a hidden population of dark worlds that outnumber the familiar star-orbiting planets by factors that challenge comprehension. These ejected worlds drift through space at velocities measuring tens of kilometers per second, racing through the galactic void on trajectories that will never again bring them close enough to stellar warmth to experience anything resembling the conditions that make planetary surfaces habitable. The physics of planetary ejection operates through gravitational interactions so violent that they literally tear worlds away from their stellar families, flinging them into space with escape velocities that exceed the gravitational binding energy of entire stellar systems. Close encounters with massive planets, particularly gas giants during the chaotic early phases of planetary system formation, can create gravitational slingshot effects that accelerate smaller worlds beyond escape velocity. The process operates according to conservation of momentum principles where the gravitational energy of massive planetary bodies transfers to smaller worlds, launching them into interstellar space with velocities sufficient to overcome the combined gravitational attraction of their host stars and planetary companions. The thermal evolution of rogue planets creates surface conditions that represent the ultimate expression of cosmic cold. where temperatures drop to levels that transform familiar materials into states unknown anywhere in stellar-heated environments. Without stellar radiation to provide continuous energy input, these wandering worlds rely entirely on internal heat sources, residual formation energy, radioactive decay, and tidal heating from massive moons to maintain any thermal activity above the cosmic background temperature of 27 Kelvin. Most rogue planets cool to surface temperatures between 25 and 50 Kelvin within 10 million years of ejection, creating conditions where nitrogen and oxygen freeze solid while hydrogen remains gaseous only in theoretical atmospheric envelopes. PSO J3185-22 represents an unusual category of rogue planet that demonstrates the exotic thermal conditions possible for worlds ejected during their youth. This free-floating world maintains surface temperatures of approximately 800 degrees Celsius through residual heat from its formation process, creating a bizarre scenario where a planet drifts through the darkness of interstellar space while maintaining surface conditions hot enough to glow with visible light. The world exists as a cosmic ember, a planet-sized coal burning in the infinite darkness, proving that rogue worlds need not conform to the typical pattern of frozen wanderers, but can maintain exotic thermal states that create islands of heat in the cosmic void. The atmospheric evolution of rogue planets depends critically on their mass and initial atmospheric composition, creating diverse categories of worlds that range from completely airless bodies to planets that maintain exotic atmospheric envelopes despite the absence of stellar heating. Massive rogue planets can retain substantial atmospheric layers through gravitational attraction, but these atmospheres undergo chemical evolution unlike anything seen in stellar-heated environments. Without stellar ultraviolet radiation to drive photochemistry, atmospheric compositions become dominated by equilibrium chemistry between surface materials and gaseous components, creating atmospheric conditions that may include exotic compounds formed through thermal processes operating at extremely low temperatures. The potential for subsurface oceans on massive rogue planets represents perhaps the most intriguing aspect of these wandering worlds, suggesting that planetary bodies ejected into interstellar space might maintain liquid water layers beneath thick insulating ice shells. Theoretical models indicate that rogue planets with masses several times greater than Earth could maintain subsurface oceans for billions of years through the combination of radioactive heating and tidal effects from massive moons. These hidden oceans would exist in perpetual darkness, heated only by geological processes and insulated from the cosmic void by kilometers of solid ice that protect liquid water from the temperature extremes that characterize interstellar space. The population statistics for rogue planets suggest that our galaxy contains a hidden majority of worlds that exist in conditions fundamentally different from those that characterize stellar-orbiting planets. Gravitational microlensing surveys have detected dozens of free-floating planets, with observations indicating that Jupiter-mass rogue worlds may outnumber stars by factors of 2 or more. Extrapolating these detection rates to smaller planetary masses suggests that Earth-sized rogue planets could number in the hundreds of billions throughout our galaxy, creating a vast population of dark worlds that drift unseen through interstellar space. The survival implications for any theoretical visitor to a rogue planet encompass destruction through thermal extremes that exceed anything achievable through conventional refrigeration technology. Surface temperatures approaching 25 Kelvin create conditions where atmospheric gases freeze solid, where metals become brittle enough to shatter under minimal stress, and where biological tissues would freeze solid within seconds of exposure. The absence of stellar radiation eliminates any possibility of external energy sources, while the extreme cold ensures that chemical reactions essential for technological systems cease to function according to familiar principles. The psychological impact of experiencing a rogue planet environment transcends the immediate physical dangers to encompass existential terror that challenges fundamental assumptions about planetary existence. These are worlds where no sun has risen for millions or billions of years, where the sky consists of stars so distant that they provide no warmth and minimal illumination, where the planetary surface exists in darkness so complete that it approaches the cosmic background radiation temperature that pervades empty space. The horizon-to-horizon darkness creates sensory deprivation conditions that would prove psychologically devastating even before the extreme cold completed its lethal effects. The discovery of rogue planets forces recognition that planetary existence encompasses far more than the familiar model of worlds orbiting life-giving stars in orderly stellar systems. The universe contains vast populations of orphaned worlds that drift alone through cosmic distances that dwarf the scale of stellar systems, creating a hidden majority of planetary bodies that exist in conditions of perpetual darkness and cold that represent the ultimate expression of cosmic isolation. Worlds condemned to wander the void in eternal night, forever separated from the stellar warmth that defines habitable planetary existence. 12. Future horrors, what we haven't found yet. While the frozen wanderers drifting through cosmic darkness represent the ultimate expression of planetary isolation and abandonment, our catalog of cosmic nightmares remains terrifyingly incomplete. The worlds we have documented, from glass rain planets to gravity prisons to stellar corpse companions, represent merely the opening chapters in a cosmic horror story whose most terrifying volumes have yet to be written. As our detection capabilities evolve and space-based observatories peer deeper into the atmospheric compositions of distant worlds, astronomers prepare to unveil planetary environments that will make our current discoveries appear hospitable by comparison. The universe, it seems, has reserved its most creative expressions of planetary torture for worlds that lurk just beyond the limits of our current observational reach. The revolutionary space missions launching throughout the remainder of this decade will possess detection capabilities that dwarf current astronomical instruments, designed specifically to probe atmospheric compositions and surface conditions on worlds hundreds of light-years distant. The Nancy Grace Roman Space Telescope, scheduled for launch in May 2027, will conduct gravitational microlensing surveys with unprecedented sensitivity, capable of detecting free-floating planets with masses as small as Mars drifting through interstellar space. The mission's 300-megapixel infrared camera will reveal populations of rogue worlds that current surveys cannot detect, potentially uncovering billions of additional orphan planets that have been ejected into cosmic darkness through gravitational violence we have yet to comprehend. The Plato mission, designed to monitor over 1 million stars simultaneously with precision photometry that exceeds current capabilities by factors of hundreds, will detect planets experiencing stellar environments far more extreme than anything in our current catalog. The mission's 26-camera array will identify worlds orbiting rapidly rotating stars that generate magnetic field interactions of unprecedented intensity, planets subjected to stellar flares that dwarf our sun's most powerful eruptions, and systems where multiple massive worlds create gravitational resonances that doom planets to eventual collision or ejection into interstellar space. Perhaps most terrifying is the Ariel mission, launching in 2029 as the first space observatory dedicated entirely to atmospheric characterization of extreme exoplanets. The mission will analyze approximately 1,000 exoplanet atmospheres using spectroscopic techniques specifically designed to detect the chemical signatures of atmospheric horror: hydrogen sulfide concentrations that would prove lethal in trace amounts, phosphine and ammonia abundances that indicate atmospheric chemistry operating under conditions unknown in our solar system, and metallic vapor clouds consisting of elements that should exist only in stellar atmospheres. The James Webb Space Telescope's continued operation throughout the 2030s will provide long-term monitoring capabilities that reveal how atmospheric conditions evolve on the universe's most extreme worlds. Current observations represent snapshots of alien atmospheric conditions, but extended monitoring will document dynamic processes that operate on scales impossible to predict from single observations. Hot Jupiters may experience atmospheric storms that span entire planetary hemispheres, with wind speed variations measuring thousands of kilometers per hour as stellar heating creates convective cells larger than Earth's diameter. The theoretical planet types predicted by current models of extreme planetary formation suggest that our most nightmarish discoveries represent only the beginning of cosmic horror possibilities. Chthonian planets, the exposed cores of gas giants whose atmospheres have been completely stripped away by stellar radiation, may possess surface densities and gravitational fields that exceed anything currently known to astronomy. These worlds would consist entirely of materials normally hidden within planetary interiors: metallic hydrogen, exotic ice phases, and ultra-compressed rocky materials that exist in states unknown anywhere in our solar system. Carbon planets formed in stellar environments rich in carbon, but depleted in oxygen, may develop geological processes that operate according to principles unknown on Earth. These worlds could maintain volcanic activity that spews liquid carbon instead of molten rock, creating surface features composed entirely of diamond and graphite formations. The atmospheric chemistry of carbon planets would involve compounds that exist nowhere else in the known universe, with weather systems where methane precipitation creates hydrocarbon lakes beneath skies filled with carbon vapor clouds. Ocean worlds orbiting red dwarf stars present another category of theoretical nightmare, where liquid water layers extend to depths of hundreds or thousands of kilometers. The pressure conditions at the bottom of these superoceans would compress water into exotic phases that remain liquid at temperatures and pressures that would instantly crush any Earth-based technology. The chemistry of these deep oceans may involve dissolved materials that create toxicity throughout the entire water column, while tidal heating from nearby massive planets creates convective patterns that continuously transport toxic compounds from ocean floor to surface. The most psychologically disturbing theoretical worlds involve planets orbiting stellar remnants even more extreme than the pulsar planets already discovered. Worlds orbiting near black holes would experience time dilation effects that isolate them in temporal bubbles where communication with the outside universe becomes impossible. A planet orbiting close to a black hole's event horizon would experience time passing thousands of times slower than the rest of the universe, creating a world effectively frozen in its own temporal framework while the cosmos evolves around it at incomprehensible speeds. Magnetar planets represent theoretical environments where magnetic field effects dominate gravitational forces in determining surface conditions. Magnetars, neutron stars with magnetic fields trillions of times stronger than Earth's, would create planetary environments where the behavior of matter follows principles unknown anywhere else in the universe. The magnetic field strength near a magnetar would be sufficient to levitate diamagnetic materials and create aurora displays that extend far beyond any possible atmospheric boundaries, while simultaneously generating electromagnetic effects that would disrupt the basic chemical bonds that hold matter together. Planets around unstable stars, variable stars, flare stars, or pre-supernova giants would experience radiation environments that vary by factors of thousands over timescales ranging from minutes to decades. These worlds would face alternating periods of flash heating and radiation cooling that create atmospheric dynamics impossible to predict using current models. The surface conditions would change faster than any biological or technological adaptation could accommodate, creating environments where the very concept of stable planetary climate becomes meaningless. The most terrifying possibility involves discovering worlds where the fundamental constants of physics operate differently than in our local region of space, creating planetary environments where matter itself behaves according to alien principles. Theoretical cosmology suggests that regions of spacetime could exist where the strong nuclear force, electromagnetic interactions, or gravitational constants maintain values that differ from those measured in our solar system, creating worlds where the basic building blocks of matter assemble into structures unknown to terrestrial physics. As we stand on the threshold of these discoveries, we do so with the knowledge that our exploration of cosmic horror has barely begun, that the universe maintains reserves of creative brutality that will challenge not merely our survival capabilities, but our fundamental understanding of how matter, energy, and spacetime combine to create planetary environments designed to exceed our most apocalyptic nightmares. 13. The detection revolution: how we find these nightmares. As we contemplate the theoretical horrors awaiting discovery by next-generation space observatories, the methods by which we uncover these cosmic nightmares represent technological achievements that would have seemed impossible just decades ago. The techniques that reveal glass rainstorms on distant worlds, detect iron precipitation in alien atmospheres, and identify planets being consumed by their own stars operate through principles of physics so precise that they can measure the chemical composition of atmospheres hundreds of light-years away with greater accuracy than early chemists could achieve in terrestrial laboratories. These detection methods represent humanity's development of cosmic forensic capabilities that transform tiny variations in starlight into detailed portraits of planetary environments designed to destroy rather than sustain life. The transit photometry method that first revealed the existence of most terrifying exoplanets operates through measurements of almost inconceivable precision, detecting brightness variations in stellar light that measure fractions of a percent when planets pass in front of their host stars. The technique requires monitoring stellar brightness with such sensitivity that Earth-sized planets create detectable dimming events equivalent to measuring the shadow cast by a fruit fly crossing the surface of a searchlight observed from hundreds of miles away. Yet this method has revolutionized our understanding of planetary environments by revealing not merely the presence of distant worlds, but the fundamental characteristics that determine whether those worlds represent oases of habitability or cosmic chambers of destruction. The Kepler Space Telescope, operating from 2009 to 2018, demonstrated the terrifying abundance of hostile worlds throughout our galaxy by monitoring over 190,000 stars simultaneously with photometric precision that revealed planetary transits lasting mere hours across observation periods spanning multiple years. The mission's discoveries shattered comfortable assumptions about planetary rarity by documenting over 4,000 confirmed exoplanets, with the vast majority maintaining conditions completely incompatible with any known form of life. The statistical analysis of Kepler's discoveries revealed that planets are common throughout the galaxy, but habitable worlds represent extraordinary exceptions to the universe's apparent preference for creating environments hostile to biological existence. The precision required for transit detection reveals not merely planetary presence but the fundamental characteristics that determine environmental hostility. Planet size can be calculated from the depth of transit dimming. Larger planets block more starlight and create proportionally deeper dimming events. Combined with orbital period measurements that determine distance from host stars, these observations immediately identify worlds experiencing thermal conditions that maintain molten surfaces, vaporize atmospheres, or subject planetary materials to temperature extremes unknown in our solar system. HD 189733b's discovery through transit photometry in 2005 exemplifies how this technique reveals worlds whose environmental conditions challenge every terrestrial understanding of atmospheric physics. The planet's size and orbital period immediately indicated thermal conditions sufficient to vaporize silicate materials, while the precision timing of repeated transits revealed orbital mechanics that place the world within the stellar radiation zone, where atmospheric chemistry operates according to principles unknown in our solar system. The Transiting Exoplanet Survey satellite, launched in 2018, has expanded planetary nightmare discovery through all-sky monitoring that observes 200,000 of the brightest nearby stars with 10-minute observation cadence. This improved temporal resolution enables detection of planets with extremely short orbital periods, the hot, close-in worlds that experience the most extreme stellar heating and gravitational effects. TESS observations have revealed ultra-short period planets completing orbits in less than 24 hours, identifying worlds where surface materials participate in atmospheric circulation through vaporization and condensation cycles unknown anywhere in our solar system. Spectroscopic analysis represents the detective work that transforms planetary detection into atmospheric horror documentation, revealing the chemical compositions that characterize environments designed to destroy rather than sustain life. The technique operates by analyzing how planetary atmospheres absorb specific wavelengths of starlight during transit events, creating absorption spectra that serve as fingerprints for atmospheric chemistry. The precision required approaches the theoretical limits of observational astronomy, detecting chemical signatures that represent parts per million concentrations in atmospheric envelopes hundreds of light-years distant. The first exoplanet atmospheric analysis, conducted on HD 189733b in 2007, revealed water vapor in the planet's atmosphere, initially promising until subsequent observations documented the glass rainstorms and supersonic winds that characterize this world's meteorological violence. The detection demonstrated that familiar atmospheric components could exist under conditions so extreme that they participate in weather systems designed to shred any visitor through atmospheric bombardment rather than provide life-supporting environmental conditions. WASP 76b's iron rain discovery exemplifies how spectroscopic techniques reveal atmospheric chemistry that violates every terrestrial understanding of weather systems. The espresso spectrograph detected neutral iron absorption lines in starlight filtered through the planet's night-side atmosphere, while dayside observations showed no iron signatures due to complete vaporization at extreme temperatures. These observations provided direct evidence of metallic precipitation, weather systems where familiar metals participate in atmospheric circulation through vaporization, transport, and condensation processes that create molten metal storms. The James Webb Space Telescope has revolutionized atmospheric horror analysis through infrared spectroscopy capabilities that exceed all previous observational instruments combined. JWST's analysis of WASP-39b created the first complete chemical inventory of an exoplanet atmosphere, revealing water vapor, carbon dioxide, carbon monoxide, sulfur dioxide, sodium, and potassium in atmospheric conditions hot enough to vaporize steel. The detection of sulfur dioxide, evidence of photochemistry triggered by stellar radiation, demonstrated active atmospheric chemistry operating under thermal conditions that exceed those found in most stellar atmospheres. The telescope's discovery of hydrogen sulfide in HD 89733b's atmosphere added another layer of atmospheric horror to a world already characterized by glass storms and supersonic winds. Hydrogen sulfide creates the distinctive odor of rotten eggs under terrestrial conditions, but on HD 189733b it exists in atmospheric concentrations that would prove lethal within minutes. Suspended in air heated to 1,700 degrees Fahrenheit and accelerated to speeds exceeding 5,000 miles per hour. JWST's thermal mapping capabilities extend beyond chemical detection to document weather patterns that operate on planetary scales impossible to observe in our solar system. The telescope can map temperature differences between day and night hemispheres of tidally locked worlds, revealing atmospheric circulation patterns that transport vaporized metals across entire planetary hemispheres. These observations document wind systems where molten iron vapor travels at velocities that exceed military aircraft speeds, creating atmospheric dynamics that would tear apart any known materials through thermal stress and mechanical violence simultaneously. The gravitational microlensing technique represents perhaps the most profound detection method for revealing the universe's hidden population of rogue planets, worlds ejected into interstellar space that drift through cosmic darkness beyond the reach of transit or radial velocity detection. The method exploits Einstein's general relativity predictions that massive objects bend spacetime sufficiently to focus background starlight, creating temporary brightening events when free-floating planets drift between Earth and distant stars. These detection methods collectively reveal that the techniques capable of finding cosmic nightmares represent humanity's development of observational capabilities that transform electromagnetic radiation into detailed atmospheric analysis, demonstrating that the universe has provided us with precisely the tools necessary to document our cosmic insignificance through the discovery of worlds designed to annihilate rather than nurture the biological processes that define our existence. 14. The comparative horror, Earth versus the cosmic torture chambers. As our detection capabilities unveil the chemical signatures of atmospheric destruction across hundreds of distant worlds, the accumulated evidence forces a profound realization that transcends mere astronomical curiosity to challenge our fundamental understanding of planetary habitability itself. Each spectroscopic measurement of hydrogen sulfide concentrations, every thermal map revealing molten metal precipitation, and all gravitational analyses documenting crushing surface conditions serve to illuminate by stark contrast the extraordinary, perhaps miraculous, nature of Earth's environmental hospitality. When measured against the cosmic catalog of planetary nightmares that populate our galaxy, our world's gentle climate, breathable atmosphere, and stable surface conditions appear not as the natural state of planetary evolution, but as a cosmic accident so improbable that it approaches the realm of astronomical impossibility. Earth's temperature range, spanning from Antarctica's record low of -89 degrees Celsius to Death Valley's maximum of 58 degrees Celsius, encompasses a variation of just 147 degrees across the most extreme terrestrial environments. This narrow thermal band, which enables liquid water to exist across vast regions of our planet's surface, represents less than 1% of the temperature range documented on exoplanets throughout our galaxy. Corot 7b experiences surface temperature variations approaching 2,700 degrees Celsius between its furnace-like dayside and frozen nightside, a differential that exceeds Earth's entire temperature range by factors of 18. The molten lava oceans that characterize this world's dayside maintain temperatures of 2,500 degrees Celsius, approximately 42 times hotter than Earth's most extreme desert conditions. The ultra-hot Jupiter Kepler 70b pushes thermal extremes to conditions that challenge comprehension when compared to terrestrial standards. Surface temperatures reaching 6,800 degrees Celsius exceed Earth's maximum recorded temperature by factors of 120, creating conditions hotter than many stellar surfaces where planetary materials exist only in plasma states unknown anywhere in our solar system. The planet survived being engulfed during its host star's red giant phase, demonstrating that worlds can endure thermal conditions that vaporize the fundamental building blocks of rocky planet formation. At the opposite extreme, rogue planets drifting through interstellar space experience temperatures that approach absolute zero, creating surface conditions where familiar materials behave according to physics principles unknown in Earth's climate system. These wandering worlds, ejected from their stellar systems through gravitational violence, cool to approximately 25 Kelvin within geological timescales, temperatures that transform nitrogen and oxygen into solid phases while making water harder than steel. The temperature differential between Earth's coldest regions and the surface conditions on rogue planets exceeds 300 degrees Celsius, creating environments where the fundamental chemistry that enables terrestrial life ceases to operate according to recognizable principles. The atmospheric pressure conditions that characterize Earth's surface environment represent another extraordinary exception to the cosmic norm of planetary atmospheric extremes. Our planet's sea-level atmospheric pressure of 101,325 pascals provides the baseline against which exoplanet atmospheric conditions reveal crushing or vacuum environments that would prove instantly lethal to any Earth-based technology or biological systems. Venus, our closest planetary neighbor, maintains atmospheric pressure 92 times greater than Earth's surface conditions, equivalent to pressures found 900 meters beneath terrestrial ocean surfaces. Yet this crushing environment appears benign when compared to the theoretical atmospheric pressures achievable on super-Earths, where gravitational fields exceeding 10 times Earth's strength could maintain atmospheric envelopes measuring hundreds or thousands of Earth atmospheres in density. The super-Earth 55 Cancri E demonstrates atmospheric pressure conditions that exceed Earth's environment while simultaneously maintaining chemical compositions that would prove lethal through multiple pathways. The planet's atmospheric pressure of 14 Earth atmospheres might seem manageable until chemical analysis reveals carbon dioxide and carbon monoxide concentrations that would cause unconsciousness within minutes, combined with hydrogen cyanide traces that represent lethal poisoning in parts per million quantities. The atmospheric chemistry operates under thermal conditions exceeding 3,500 degrees Celsius, creating gaseous environments where familiar atmospheric components participate in chemical reactions unknown anywhere in terrestrial atmospheric science. The radiation environment that characterizes Earth's surface represents perhaps the most extraordinary aspect of our planet's habitability when measured against the radiation levels documented throughout exoplanet populations. Earth's natural background radiation of 62 millisieverts annually provides protection through our magnetic field and atmospheric shielding that enables complex biological chemistry to operate without continuous radiation damage. Mars, lacking magnetic field protection, experiences radiation levels approximately 100 times higher than Earth's background, sufficient to pose significant health risks but manageable with technological shielding for limited periods. The pulsar planets orbiting PSR B1257+12 demonstrate radiation environments that exceed Earth's background levels by factors measuring in the millions, creating surface conditions where high-energy particles deliver doses equivalent to nuclear explosions every second for billions of years. The radiation intensity approaches levels found during stellar formation processes, maintained continuously by neutron star emissions that sweep across planetary surfaces with clockwork precision. Any biological tissue exposed to these conditions would experience molecular destruction at rates that exceed any conceivable repair mechanism, while electronic systems would suffer component failure within microseconds of exposure. The atmospheric chemical compositions documented on exoplanets reveal toxic environments that would prove lethal through mechanisms unknown in Earth's atmospheric chemistry. HD 189733b's atmosphere contains hydrogen sulfide concentrations suspended in air heated to 1,700 degrees Fahrenheit and accelerated to speeds exceeding 5,000 miles per hour, creating atmospheric conditions where familiar toxic compounds participate in weather systems designed to deliver chemical and thermal death simultaneously. The planet's glass rain storms represent atmospheric violence where silicate particles, harmless as beach sand under terrestrial conditions, become weapons of atmospheric destruction through combination with supersonic wind velocities. WASP 76b's iron precipitation demonstrates atmospheric chemistry where elements essential to technological civilization become agents of atmospheric annihilation. Iron, the foundation of human industrial development, exists in this world's atmosphere only as components of weather systems that rain molten metal heated to 1,500 degrees Celsius through atmospheric circulation patterns driven by winds exceeding 18,000 kilometers per hour. The metallic precipitation represents familiar materials transformed into atmospheric ammunition through thermal and dynamic conditions that exceed anything achievable in terrestrial industrial processes. The gravitational field strength that characterizes Earth's surface, 98 meters per second squared, enables the evolution of complex biological structures and technological systems that operate according to familiar physical principles. The super-Earths scattered throughout our galaxy demonstrate gravitational conditions ranging from merely challenging to absolutely crushing, creating surface environments where human bone structure would fail under its own weight and cardiovascular systems could not maintain circulation against gravitational loading that exceeds physiological limits. When Earth's environmental conditions are measured against this cosmic catalog of planetary torture chambers, our world's habitability emerges not as the expected outcome of planetary formation, but as an extraordinary convergence of factors so unlikely that it approaches cosmic coincidence, a rare sanctuary of gentle climate in a universe that specializes in creating worlds designed to destroy rather than nurture the delicate chemistry that enables life to emerge and flourish. 15. Conclusion: a universe designed for destruction. As we emerge from this comprehensive survey of cosmic horror spanning from glass rain worlds to gravity prisons, from planets being devoured alive to worlds drifting in eternal darkness, the accumulated evidence paints a portrait of our universe that challenges every comfortable assumption about the prevalence of habitable environments and the likelihood of life emerging beyond our own world. The thousands of exoplanets documented through decades of astronomical observation reveal a cosmos where Earth's gentle hospitability represents not the expected outcome of planetary evolution, but rather a cosmic anomaly so extraordinarily rare that it forces us to confront the possibility that we inhabit not merely an unusual world, but perhaps one of the only sanctuaries of biological possibility in a galaxy designed to prevent rather than encourage the emergence of life. The statistical analysis of confirmed exoplanets provides numerical confirmation of what our detailed exploration of individual worlds has revealed through atmospheric chemistry and environmental documentation. Of the more than 5,500 confirmed exoplanets cataloged by astronomical surveys, fewer than 50 maintain conditions that fall within the theoretical boundaries of habitability. A success rate of less than 1% that suggests habitable worlds represent extraordinary exceptions to cosmic norms rather than expected outcomes of planetary formation processes. Even these potentially habitable candidates face challenges that may eliminate their capacity to support life when subjected to detailed analysis of atmospheric evolution, stellar radiation environments, and long-term climate stability. The discovery that most stars in our galaxy host planetary systems initially seem to promise abundant opportunities for life to emerge throughout cosmic space. Yet the detailed characterization of these worlds has revealed that planetary abundance does not translate into habitable abundance. The Kepler Space Telescope's statistical analysis demonstrated that virtually every star possesses planetary companions, creating a galaxy containing hundreds of billions of worlds. However, this numerical abundance becomes cosmically insignificant when filtered through the narrow requirements for maintaining liquid water, stable atmospheric chemistry, and surface conditions compatible with biological processes. The categories of planetary nightmare we have documented represent systematic violations of habitability that operate through different mechanisms but achieve the same result: the creation of environments where life cannot emerge, survive, or evolve beyond the most primitive states. Hot Jupiters like HD 189733b and WASP-76b demonstrate how close stellar proximity transforms atmospheric chemistry into weapon systems that rain glass and molten metals. Super-Earths reveal how gravitational forces can create crushing conditions that exceed the structural limits of biological systems. Pulsar planets show how stellar death creates radiation environments that sterilize worlds more thoroughly than any conceivable sterilization process. The rogue planets drifting through interstellar space represent perhaps the most profound challenge to assumptions about planetary habitability, demonstrating that worlds can be ejected entirely from stellar heating and condemned to exist in cosmic conditions where temperatures approach absolute zero for billions of years. Current estimates suggest that these orphaned worlds may outnumber stellar orbiting planets by factors of 2 or more, creating a hidden majority of planetary bodies that exist in conditions completely incompatible with any known form of life. The implications for astrobiology, the search for life beyond Earth, force a fundamental reconsideration of where and how we might discover biological processes operating in cosmic environments. The traditional concept of habitable zones around stars, where liquid water could theoretically exist on planetary surfaces, proves inadequate when confronted with the reality that worlds within these zones may maintain atmospheric compositions, pressure conditions, or radiation environments that eliminate any possibility of biological chemistry. The habitable zone becomes meaningless when populated by worlds with crushing atmospheric pressures, toxic chemical compositions, or gravitational fields that exceed the structural limits of organic molecules. The search for life must now account for the possibility that biology represents such an extraordinary cosmic rarity that it may emerge on fewer than one planet per galaxy, making Earth not merely unusual but potentially unique among the hundreds of billions of worlds that populate the Milky Way. This possibility forces confrontation with the concept that intelligence capable of contemplating its own cosmic significance may represent the rarest phenomenon in the universe, more unlikely than stellar formation, planetary accretion, or any of the cosmic processes that create the astronomical structures we observe throughout space. Yet the continued discovery of exoplanets operating under extreme conditions provides unprecedented natural laboratories for understanding how matter behaves under temperature, pressure, and radiation conditions impossible to replicate in terrestrial facilities. The glass storms of HD 189733b reveal atmospheric dynamics under supersonic wind conditions. The diamond precipitation of carbon planets demonstrates high-pressure chemistry that expands our understanding of how familiar elements behave under extreme conditions. The iron rain of ultra-hot Jupiters shows metallic phase transitions in atmospheric contexts that provide insights into material science under conditions exceeding industrial capabilities. These discoveries suggest that while the universe may prove hostile to biological evolution, it excels at creating natural experiments in extreme physics that advance our understanding of how matter, energy, and space-time combine under conditions that push physical processes to their theoretical limits. Each glass rain storm, each molten metal precipitation event, and each instance of planetary consumption by stellar companions teaches us more about the fundamental forces that govern cosmic evolution. The philosophical implications of inhabiting a rare sanctuary in a universe of planetary torture chambers challenge anthropocentric assumptions about our cosmic significance, while simultaneously elevating the value of Earth's environmental stability. If habitable worlds represent cosmic accidents occurring in less than 1% of planetary systems, then Earth's biosphere becomes not merely valuable but irreplaceable, a unique repository of biological possibility in a cosmos that specializes in creating conditions hostile to the emergence and evolution of life. The coming decades of astronomical observation will undoubtedly reveal worlds with conditions even more extreme than those documented in our current catalog of cosmic nightmares. The James Webb Space Telescope and next-generation ground-based observatories will probe atmospheric compositions and surface conditions on thousands of additional worlds, likely discovering categories of planetary horror that exceed our current understanding of how hostile environments can become. Each new discovery will further illuminate the extraordinary nature of Earth's habitability, while expanding our appreciation for the universe's creative capacity in devising new methods of planetary destruction. As we continue exploring this galaxy of nightmares, we do so with the knowledge that we are investigating a cosmos where our worst fears about alien environments represent not science fiction speculation but documented reality, where planets rain glass and metals from toxic skies, where worlds burn with ice and freeze with fire, and where gravity itself becomes an instrument of systematic torture. In this context, Earth emerges not as a typical world but as a miraculous exception, a rare garden of biological possibility flourishing in a universe that appears designed to destroy rather than nurture the delicate chemistry that enables life to emerge, evolve, and contemplate its own cosmic insignificance in the vast darkness between stars.